Hi everyone. So today I'm going to be talking about two things that really made light click for me. Lambert's cosign law. So the first thing I'm going to be starting with is Lambert's cosign law. This is the idea that brightness depends on the angle of incidence. So I've learned this from Dorien Iten. Highly recommend going to him to learn more of this. But basically, if light comes down, hits a plane, front on, you're going to get 100% brightness, right? That's brightest it's going to get. If you hit it from another angle, slightly further down, right, slightly tilt it, it's actually not going to change that much. It's going to be about 99% brightness. If you tilt it just a slight bit more, that's probably going to be something about 90, kind of like 90, I was thinking, um, or 97. And this just kind of continues. It's a very slow gradation. Not much changes in the lights as it turns, even though you feel like it should. So generally, how I like to think of it is I view it as like a roller coaster, right? Just as it's reaching the top of that curve, right before it plummets down. So you're at the top, inching your way forward, just a little bit at a time. Nothing much is changing, right until you get to that point where you start falling, and you're gonna fall really fast. You're gonna plummet down. Or in this case, if we're thinking of it like light and shadow, you're gonna start at the lights. Nothing as much is gonna change in the value of it. It's gonna stay very, very close together. And then once it starts getting close to the terminator, right before it falls in shadow, that's that turning point where it's gonna plummet. Right before it plummets. So it's gonna start going dark very quickly. And then it hits the shadow. So the darkest you're gonna get in halftones, light halftones, dark halftones, that's more rendering. I'm gonna get into that in another video. The dark halftones are right near the terminator. They're like right at the edge of it. There's only like a small group of those. So let's take a normal value scale. Here's the issue with a normal value scale. In of itself, it's fine, right? But when applying it to curves, to shadows and whatnot, here's the issue with it. So, as you learn value scales, it's incremental steps down. It's very equal, you know. It like almost immediately starts going dark, right? But if it's on the roller coaster, it's gonna go reaching toward the top. Not much is gonna change until it starts hitting that darker halftones where it's gonna start plummeting down in shadow. So if I reapply this, how it's supposed to go, the Lambert cosign law to this one thing. I'm drawing this line here. This is going to be the terminator for an object. And then the blackest this is going to be shadow. So we're going to go to the brightest. And then it's going to go just a tiny bit down, as you remember with that 99%. Then it's going to go tiny bit more down. We're holding on to that light. It's like the light doesn't want to go dark right now. It wants to hold on as much as it can. And we're getting close to the terminator now, so it's going to start going into dark halftones really quick, which is what I'm doing here. And then this is the darkest halftone you're going to get right before it goes into shadow. So proportional wise, there is more of the lighter halftones here than there is of the darker halftones. So we have a huge chunk of light halftones, we have a tiny little strip of dark halftones, and then we have the strip of shadow, right? So if we were to apply this to a sphere, let's say, we have the shadow right here. Then we just have a tiny little strip. This is going to be the dark halftones. You're going to go shade your way out from the shadow. You're going to go darker, but then almost immediately you're going to start going lighter, right? Because you're going to fill that strip almost with one stroke, depending on the brush you're using. almost immediately go light, like you're barely touching the paper. Second thing I want to get into is something called light fall off. This is just the idea that light loses energy, right? There are two ways light can lose energy. Number one, through distance, and then number two, through bounce. The reason light loses energy through distance is due to something called the inverse square law. I don't know the exact bits of it, but basically how it works is that as you double the distance or triple the distance, it gets like squared, the light. So at double the distance away from the light, you have 1/4 of the original power. And at triple the distance, you have about 1/9 of the original light strength. So it's just a small little thing. Basically, through this, we see that light just dies off really quick, especially depending on the strength of something, right? So it also depends on the strength of the light, right? If it's something like the sun, it's going to go on really long, right, before it dies off. We can't see, like, when it dies off because it's like, it goes really far off past the Earth. But if you take something like a candle, a small flashlight, maybe a house light or something like that, you're going to see that fall off more evidently. So yeah, you're going to see that fall off pretty much immediately. And then, getting into bounce, every time it hits at an angle, coming back to that cosine law, you lose the original strength of the light. So here, I made a little animation showing that, like, as you bounce like a ball, you lose the energy. So same thing happens with light. It can also change depending on the material that the light bounces on. If it's something like cloth, we have all these fibers in here, it's not really going to bounce. The fibers are kind of just going to eat the light. So if you do get any bounce, it's very, very little. The material changes how it bounces. If it's very reflective, it'll bounce way more light. If it's very cloth, toothy, it'll reflect less. So here I'm doing a comparison between direct light and bounce light, right, just to show how much energy you lose. So the direct light hidden in the side of the ball, you can see it there. It's fairly bright, right? That's what's getting hit by the direct light. But once it bounces off the floor and then back into the shadow, like, here's the direct light, and here's the ambient light I chose, or the reflected light I chose. See, like, how far away from each other they are? That's how much strength you lose with just one bounce. Anyway, two things that helped me the most: Lambert's cosign law and light fall off. These two things, very powerful when understood, and I think they really help you a lot. Second video, I'm going to be going into light on form. I'll be delving more into ambient light, types of light, light edges. I'll be talking about the lighter halftones, dark halftones, reflected light, shadow, and other various light things, light and shadow things like that. So in the meantime, I wish you all a good day.